Hello everyone, today let's solve the problem number 416, partition equal subset sum. So what the question states here, we are given an array nums, you can clearly see here, we are given an array nums consisting of the positive integers. So clearly they have mentioned it consists of the positive integers, you can clearly see here. Our goal is to determine whether we can partition this array into two subsets. So what is our goal? Our goal is to determine whether we can partition this particular array, whatever the array they have given, into two subsets such that the sum of the elements in both subsets is equal. So the sum of the elements in the both the subsets has to be equal. So here if it is equal we have to return true, if it is not equal we have to return false. In this case just this one you can clearly see here they have mentioned in the explanation the array can be partitioned as 1, 5 and 5 here. So you can clearly see nothing but 5 plus 5 plus 1 is nothing but 11. Here first we will sum up all the elements. This will lead to 22, right? 10, 11 plus 11 leads to 22. Here this partition you can clearly see here 1, 5, 5 leads to 11, nothing but half of it, right? That's what they have given here. So the partition of the array into two subsets, right? So our goal is to determine whether we can partition the array into two subsets such that the sum of the elements in the both subsets is equal. So here this is one subset and this is one subset, right? So here this is means this is 11 and 11, and when we sum up this one it will lead to 22. So here the solution is correct, right? Let's come to example 2 here. Nums they have given elements here 1, 2, 3 and 5. Output is false in this case. Why output is false they have given here? So the array cannot be partitioned into equal subsets at all here, some subsets at all here. So the output here they have given false, right? So I hope the question is completely clear. Let's discuss the this one approach step by step, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So let's discuss the approach step by step. So here we'll be making use of the bit set approach, or we'll be going with the bitwise dynamic programming, nothing but bit masking, right? We'll be using the bit set approach to determine whether a subset sum equal to half of the total sum exists, right? So that's what we'll be doing here. So we just have to keep in mind that we'll be going with the bitwise dynamic programming right here. So I have considered the same example that they have given in the question. First example that they have given in the question, I have considered the same. Let's see this one step by step. First, what we will do, we have to compute the sum of elements here. Sum of the elements here, yes, you can clearly so we can come here 1, 5, 11 and 5 are the elements, right? 1, 5, 11 and 5. In this case here 5 plus 1 6, 6 plus 11 is nothing but 17, 17 plus 5 here 22. So we have 22 here, right? So next move on to the next step. If S is odd, then we cannot partition into two equal subsets. So if S itself is odd here, we cannot partition that one into two equal subsets. In this case we have even number, right? 22. So here S is even, means here just give me a second here. Here S is 22. In this case we have even number, right? So in this case S is even, so we can continue. Let's move on with the this one, step 3. So our target sum for each subset here is S by 2, right? Nothing but here 22 by 2. In this case it has to be 11, right? So we will be making use of the bitwise dynamic programming to track the subset sums. So here we'll be making use of the bitwise DP, as I have said. We will be iterating through the each this one. We will be iterating through the each number in the nums array and update our possible sums using the bitwise or equal to this one. We'll be making use of bitwise or, right? Or equal to. So with left shift operator, double left shift operator, this one, left shift operator, right? So this one will be making use of. So if the target sum 11 is possible to form using the elements of nums, then what we will do, we will return true in this case. So here, let me come here. Here, if the target sum 11 is possible to form using the elements of nums, we will return true. Otherwise, we have to return false, right? So we find that 11 is achievable. Achievable, when I say 11 is achievable, 1, 5 and 5. This is 5 plus 5 is nothing but 10, 11, and 11 is another subset here. So here, answer will be, in this case, we have to return true, right? I hope this is completely clear, right? So this is the approach that we will be going with. Let's discuss the edge cases one by one. First thing is smallest case here. Nums, we have only one element, so output is false in this case because we cannot partition a single element. In this case, output will be false, right? So let's come to the second example here. All equal elements. We have all equal elements here, 3, 3, 3 and 3. So output will be true here. Why? Each subset gets here 3 comma 3, right? So the output will be true in this case. So what will be the third edge case here? I have considered, so we have to consider odd sum case. When I say odd sum case, it is 1, 2, 3, 5 here. I have considered nums array, the elements 1, 2, 3, 5. Output will be false here in this case because sum is 11 in this case. You can sum up this one, 1, 2, 3 and 5. 1 plus 2, 3, 3 plus 3, 6, 6 plus 5 is nothing but 11. So this one is odd. When the sum is odd, it cannot be partitioned, right? So we have already discussed this one in the question, in the example that we considered, right? So this for this case, output will be false. The final edge case here is large elements. When I say large elements, it is I have considered 100, 400s as elements, right, within the array. So here output will be true in this case because each subset gets 100 comma 100, right? So I hope all the edge cases are clear. The first edge case that we went with here is smallest case. The second edge case that we went with here is all equal elements. The third edge case that we went with here is odd sum case, and the fourth edge case that we went with here is large elements. I hope all the edge cases are clear here. So now what we'll do, let's start writing. So first thing, what I'll be doing here, we have to compute the total sum of the array elements, right? As we have discussed in the approach, we have to compute the total sum of array elements. I'll be making use of reduce here. So let s equals, in this case, a dot, let me make use of here reduce to the this one single element. We are summing up all the elements in the array in this case, right? I'll just give here a plus c. This is fine. So the next step here is, if the sum is odd, it is impossible to split equally. We have discussed this one, right? So in this case, let me make use of ampersand here. So we are going with the bit masking, right? Or this one, we are making use of r, and we are making use of the left shift operator here in this case. So here, if s and 1, this one, then what we will do, we will return 0 in this case. Nothing but here, if the sum is odd, means here, if sum is odd, that is why we are making use of this operator right here. If the sum is odd here, we have to return 0. I hope this is clear. So the next step here is, we have to initialize a bit mask dp with 1, right? So we have already discussed the base case, subset sum equals 0 in this. I mean, it is always possible. I mean, when subset sum equals 0, it is always possible, right? So this is the base case. So we have to initialize a bit mask dp with 1. So I'll just give here dp equals 1n. This is fine. I hope this is clear. So next, let's iterate through each number in A. So we have to iterate through the each element that is present in the array, right? So I'll just, so what happened here? It has to be for this one. Let w of A. This is fine. Within the for loop, what I'll do, let's update the bit mask. When I say let's update the bit mask, so shift left, what we will do here, we'll be making use of the left shift operator. Or when I say update bit mask, we will update shift left by W positions and or it with the previous state. So I can write in this way. We have already discussed this one. Or equal to, we'll be making use of, I said, right, during the approach. So this one. So we are updating bit mask here means we are making use of shift left by W positions and or it with the previous state. So I can articulate this one in the form of code in this way, right? DP left shift operator here with, oh sorry, let's go with the begin here, begin of W. So this is fine. So final step, we will check if the target sum 5 by 2 exists in the bit mask. So here in this case, we can just write in this way, DP again, this time right shift operator will be making use of. So here this will be begin of sum by 2. This one we will check whether sum by 2, nothing but in this case we had seen it was 11, right? So sum by 2, this one, these the subsets exist or not, we have to check that one, right? We have to check if the target sum s by 2 exists on the bit mask or not. And this, how can we articulate that one in the form of code? S by 2, this one I'll just make use of ampersand 1 n, because we are making use of the begin here, 1 n, don't get confused here. So we are making use of the begin here. So everywhere wherever you are making use of 1, after this one initialization of the begin, wherever we make use of 1, we have to give n at the end. So let me format this one once and let me hit the run button. I hope this works. Let's see. We have the this one a is not defined. So here, okay, so we are going with the nums here, right? So this one has to be, or did I use a anywhere here? So yeah, so let me make this nums. Why I have given a here? This is fine. So let me give here nums. So let me hit the run button here again. Let's see. Yeah, now you can clearly see the sample test cases are getting passed. Means let me hit the submit button very quickly. So you can clearly see all the test cases are getting passed here. Means the code works absolutely correct in this case, right? So the next step here, the final step, let's discuss the complexities of the code that we have written. So the approach that we went with here is bitwise dynamic programming or bitwise DP, right? So overall time complexity here would be big O of n into this one, sum by 2 in this case. So what will be overall space complexity here? Overall space complexity would be big O of 1 in this case. So why it is here big O of n into sum by 2? Because we are making use of the bitwise operations here. You can clearly see somewhere, just give me a second here, this one, sum by 2, this one. Due to this one, the overall time complexity is big of n into sum by 2, but it is optimized due to the bitwise operations, right? So this is one thing we have to keep in mind. So overall space complexity here is big of 1 because we are making use of constant space using bit set that is stored in the single integer, right? So I hope this is completely clear. So the overall time complexity would be big of n into sum by 2 and overall space complexity would be big of 1. So I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.